Hello, today we are going to continue our work with logs and exponentials, and we're going to be doing some problem solving, which really just means we're going to be interpreting some English. There's no real new maths here today. This is just going to be looking at how we take an English text, translate it into maths, and do some work with it. That said, you won't have used this formula in a little while, most likely. It's going to be the compound interest formula, but we'll get into that now. €1,000 is invested at 2% compound interest. Now, instantly, if I'm in an exam, I see the word compound interest, and by the time we're going for our exams, we're going to know that means I open up page 30 in my log tables. Log tables page 30 gives me my financial maths, equations, and stuff about compound interest. So before I do anything else, I see that I'm investing one block of money for a particular amount of time. I'm going to open up page 30 in my log tables and write that formula down. I don't need to know what the question is yet. That information is going to be needed. So before I get into the weeds of the question, I'm opening up page 30 and writing my formula. Now, part 1. What is its value after 2 years? Fairly straightforward question when we're used to these. And you will be much more used to this language once we have looked at the financial maths chapter. So €1,000 is the P in this formula. It's called the present value sometimes, and traditionally it's called the principal. So P is the money we start with, and it's €1,000. Financial maths questions are not terribly mathematically complicated, but they do require you to lay things out very carefully. My interest is 2%. That's the I in my formula. It's 2%, which I never deal with percentages directly. That's going to be 2 over 100, or 0.02. I recommend in an exam you do that in the calculator, even if normally you would be able to do that conversion very easily in your head. Very commonly, students will write down 0.2 instead of 0.02 or equivalent errors. So it's a good idea to rely on the calculator when you start dealing with fiddly decimals in an exam setting. And T, we're told in part 1, is going to be 2 years. So I'm looking for F, which is the final value. So I write down my formula and then sub in. Very little exponentials in this part of the question, but it is still important that we're set up for how this formula works before we do a little bit of rearranging with it. There's nothing else I need to do here. I can simply put that into my calculator and I get €1,040.40. So that's the amount of money that would be in the account at 2% compound interest over 2 years. Now, part 2. How many years, after how many years will the investment be worth €1,104.08? So let's get into part 2. What information do we know? We still have our starting value is going to be €1,000. Our interest rate is still going to be 0.02. T is now something we are looking for, and F we're given is 04.08. So if I sub that into my formula, I have 1104.08 is equal to 1,000 on 1 plus 0.02 to the power of t. I now need to find out what t is, so this is where we get into our exponentials work. There's two ways to solve the problem, but the initial setup is going to be the same. We are going to isolate the thing with the power. So I'm going to divide both sides by 1,000 to get rid of that 1,000 in front of my exponential part. And I am going to get 1.10408 is equal to 1.02 to the power of t. Now this is not me being pedantic. These types of questions are going to be very sensitive to minor changes. So when you're dealing with powers and logs, you're going to keep more decimals than you usually would. So effectively, you try to store the values as you go in your calculator and write down 6 or 7 decimal places if they become relevant. Because when you're dealing with some types of financial maths questions, small changes will add up to very big differences by the time you're finished the question. Not so much in this one, but it is an important habit to be in if we're dealing with financial maths or if we're dealing with exponential and logarithmic functions. Small changes can give very big differences, so we need to be careful that we're keeping more decimals than normal. Now, we have two choices at this point. I'm going to show you the general safer choice, and then I'm going to show you what we might expect to do based on some of what we've done in the past. I want to get this power down, so I'm going to take the natural log of both sides. In this type of equation, it will pretty much always be safest to take the natural log of both sides. 1.10408. I have a power inside of my log, so I'm able to take that down and out. I end up with ln of 1.02. I divide both sides by my ln of 1.02. And when I do that, I will find that t is equal to 4.99996, which I will say is approximately equal to 5 years. Now the other way of approaching this, this step would be to use a novel base to take the log to the base 1.02. And I'm showing this to you because you may see it in other contexts. It's not what I recommend you do. It is technically very slightly quicker, but it is much more prone to error. So I am showing it to you so you understand where it comes from. It is not what I recommend you do. So you would take log to the base of our number, and I will remind you of why we might want to do that in a moment. Log to the base 1.02 of that. If I have log to the a of a, I end up, log to the base a of a to the x, this is just x, because any number to what power on any number would just be 1. So this part becomes 1, and I'm just left with t on the left hand side. And when I put this into the calculator, I get 4.999 and so on again. I am only mentioning this because you may see it elsewhere. This is not an advisable way to approach these questions in my experience because of the chances of making an error with putting in a base that is a non-standard one. Taking natural log of both sides and taking down your power as we did here is much safer.